nice to see you again. 10 production pitfalls to avoid. 10 is not enough. There's, I think all of you know, thousands of them, so I've just randomly chosen them. They're not in any order. So borderline best practices, which is the best way to prevent the pitfalls. So you might recognize some of the images that Govind had. If we say 10 pitfalls, I'll just quickly go through it. We reduce your waste processes through better planning, control overproduction and excess stock, respect your production space, optimize material handling flow and storages, create efficient workplaces, understand your production capacities, implement correct maintenance schedules, understand the importance of product engineering and standardization, my favorite, if anybody knows me. Create correct production documents and understand the importance of correct quality control. Waste processes we all have, but waste processes are not what your clients pay for. The clients pay for a product and not the amount of time the product spends on your shop floor. Waste processes are machine downtimes, overproduction, inefficient material handling, searching, rejects, waiting. These are all waste processes which we really don't need in our production. Also, waste process is in your machines. Waiting times, setup times, these are kinds of processes that we really have to avoid. And these we can actually only avoid through correct planning. Overproduction. Most of the producers that I see on a daily basis, they overproduce. They have, I think, they have a bad conscience about machines not running. Even though they have so much material in stock, they'll just carry on producing just to make sure that the operator is not sitting idle, but that's not the point. If you reduce all of your stocks, all of your material in process, all of your excessive stocks, you actually start to understand what happens in your production. As you can see, if there's a nice, does this work? There's a nice image over here. The water level is your production, so your water level is very high, so you can't see all the rocks below the level. So if you reduce the stocks that you have down below, then you can start understanding the defects that you're having, the wastage that you're producing, all these kinds of things. You start getting a better understanding of it. So the idea is to lower the water level, realize and know your problems, solve the problems, of course, and get an efficient production, make more profit. A nice example of a little bit of overstock. This is a nice kitchen production with a lot of stock, so this is something that you wouldn't want. Respect your production space. Once again, there's so many factories that when I visit them, effectively, you would see that their finished goods is taking up most of the space. Their production is actually taking the least amount of space if you're talking productivity, and that is not the point. The point is to increase your production space so that you can actually produce more, supply more, sell more, have much more products out in the market. This is the kind of situation that you get to see in many factories where they're sitting on all these packed materials, packed goods. And of course, it's 99% of the time it's the customer's fault because his site isn't ready. So that's the point. But there must be a way of reducing this type of excess. Optimizing your material flow, your in-house logistics, storages, these kinds of things. A bad example of material on the shop floor. People like to work with pallets, keep everything grouped. Understand that where the products are lying, but to access is very difficult. So important is to plan your facilities, plan your material handling, plan the movements in your factory so that you can access your products in the correct sequence all the time. A nice example where you have, this is a rollerized production, but everything is in sequence. This is a first in-out type production where you do require a bit more discipline in your production, but the handling is far easier, the damage on a product is much less, and everything is just much smoother. Also, less manpower required to move your product. famous trolleys. Bad example of material handling, again, funny pallets or funny trolleys. This is a method that we do with a number of our manufacturers, even in Greater Noida, was the first one that we implemented. So the idea is that it's the sorting or picking concept, where you can produce in batches, where all the parts are accessible. You don't have to remove parts to access the parts below in the bottom of the stack. So whichever part you need, if you need a certain type of drilling, a certain type of edge banding, you can just pick the part, do the process, put it back, and everything is fine. A better example of storages, most of the factories, even if they're multi-level, they have a good amount of ceiling height. But nobody seems to utilize the ceiling heights. They don't utilize the volume of the air that you have. Everybody's just using the floor space, complaining about how much the square meter or square foot costs, but not realizing that there's so much above the floor which nobody uses. And just by installing a very basic racking system, a little bit of discipline, you can really be far more efficient in the storages. Creating efficient workplaces. Once again, the standard procedure in many factories is assemblies on the floor or on very sort of rudimentary types of assembly stations, which is it's ergonomically not viable. The chance of damage is much higher. So we need to start thinking about creating workspaces for our assemblers or workers or whoever's doing the work, and thinking about these systems of how to do it in a better way. This is an example of a workstation, assembly station for a repeat product, so it's not a flexible station, but the idea is the feeding of the station, the trays with the hardware and the equipment. There's always two behind each other, so they get fed from the back. And then when the box is empty, the operator puts it on top, it slides down to get collected from the other side. So it's a very sort of high-tech type of assembly station. If we're talking about workers working effectively, not even just the working effectively, but also a huge topic that I have with many of my clients is when the factory starts in the mornings. Govan had mentioned the cleanliness. When they come in the morning, the factory should be spot clean and everybody should start working immediately, which is definitely a good thing. Because if you see the amount of time, if you add it up to a year, nobody really realizes that when you multiply this into 365 days or 300 days or whichever amount of days that you're working, it really adds up. So if you're losing just 5 minutes a day, it's 2.5 days per year, and it just goes up and up and up. And if everybody wastes 1 hour every day, that's 1.5 months every year. So you'll be paying somebody for 1.5 months for doing nothing, and that is a lot, especially if you're having workforces in the hundreds. It really adds up, and it's something that everybody should really think about, and not think about increasing workforce or not think about starting overtime policies, but really think about how to plan your productions to get the most out of what you have in the 8 hours that you have. Workplace arrangements, storages of tools, all these kinds of things. There are so many easy, simple solutions out there that you can really do to make the life easier and more efficient for everybody. My most favorite picture, I love it. It's not an ergonomic workplace. I call this the PTP. If anybody knows CNCs, the PTP is a CNC drilling machine. The setting was just wonderful. But this is not how it's supposed to be. Understand your production capacities. I think most manufacturers don't really know how much they can produce. They really don't know how much their machines can actually do for them. How many parts you can drill in a minute, or how many meters you can edge band in a day, or how many parts you can edge band in a day. If you were to ask your machine suppliers, they can tell you. Really they can. They have all these values and data that you can really have and understand theoretically how much you can do. So your challenge to a manufacturer would be to try and achieve 100% capacities on your machine, and not add machines, but first, again, comes back to planning. Plan your production in such a way that you're really using all your capacities, understanding how much your machines can do to really understand what you can get out of them, and also to help you plan your production when you're planning deliveries and planning all these kinds of things. So you need to know cuttings, all kinds. There's all different kinds of processes that you can look at. If you're looking at edge banding, cutting, drilling, even sanding stations, manual stations, everything has a value to it. If it's a value that is not machine driven, you can also measure the time over a longer period, take an average, you know your capacities. Just a basic example of a capacity calculation. We do it in parts and in percentages. So in kitchens, you have your standard parts, you have your non-standard parts, you have narrow parts, you have wide parts. So all this you define because you don't want to do all the processing of all the parts basically on the same equipment, because you can start using specialized equipment to do much faster processes. So you define your capacities, you understand the parts, and then you understand your capacities. Maintenance. Now you have all these wonderful fast-moving machines, but you don't maintain them, so they never work, and then your capacities don't work either. So maintenance is a very, very important topic, which it's most people think is secondary, but I think it's one of the most important things in a factory, in a production, because you spend so much money, you invest so much money on all this really nice equipment, and then you expect it just to function all the time. When people buy good cars, they really follow the mileages. They service it at 5,000 kilometers, or Suzuki at 3,000 kilometers, Volkswagen at 15,000 kilometers. There's various service intervals, but even in machines this should be done. Even in tooling this should be done. It really needs to be taken very, very seriously. That's a nice example about sharpening the saw blade. They don't have time to maintain their machines. You should always have time to maintain your machines. Now we start moving into my favorite topics about the product engineering. Cost creation. The cost creation is a very, very sensitive issue. The product that you make creates the cost. Not your investment, not your customers, nobody, but the product that you make and how you make it. So if you understand how to make a product really well, and I must say the Chinese are very good. So mention that if you want 50% discount, they'll engineer it to be 50% cheaper. You can do it. So it's a very, very important factor. The most important factor in everything is how you create the product at the price that you need to sell. You cannot think that by making a product in any which way is the same price. It's not. Certain machining processes are involved, certain raw materials are involved, the amount of hardware used is involved. So really, if you invest much more time in this product engineering, you can be much more successful. Understanding the importance of the product engineering and standardization. Targets, like I'd mentioned, the targets of the product standardization, and in the sense of kitchens, the kitchen is the most wonderful product to standardize. It's also the easiest product to standardize because it's supposed to be standard. It's not supposed to be like all different heights and widths. So by standardizing kitchens, you reduce the number of components, so you're reducing the number of machine settings. If you know your standardized parts, you can actually create batches for standard parts where you can process in a faster, more efficient way, because these parts can be used in multiple products. By creating batches, you're reducing your setup times. Now everybody's talking batch size 1 with very big automated machines, but we're not really there yet, so we still have some more basic machines where the method of producing in batches is still more efficient for us, but not too big and not too small. So this we have to understand out of the product standardization, which then, if you're reducing your setup times, if you think of the second or the third slide, the machine setup time, you can actually manipulate by playing with your batch sizes. So you can utilize the machines much more, coming back to the capacity of the machine, trying to utilize maximum capacities of your machines. And then, of course, increase your output. principles, these standardized modules, dimensions, again coming back to the kitchens, the kitchen has normally the 50 millimeter steps, the standard heights, working in the system 32 hole lining, which matches the hardware. So all these kinds of standardizations, standardized material, also standardized raw material suppliers, which Govind had mentioned, because it's always a risk if you don't have standardized material. Because if you keep on experimenting with various suppliers, various materials, you're never really sure about the quality. So if you ever do find something good, stick to it. Don't change from that. Which then, if you're standardizing the dimensions and modules, you have standardized your hardware, and which again standardize your drilling patterns, which again helps you with your machining. Just an example of a irregular type of drilling patterns which doesn't make sense. If you standardize this type of thing, because the products are all pretty similar, a side panel always remains a side panel, the top panel remains a top panel. So you can always think about keeping distances the same, like here, so that your setup times are reduced. This is a better example. So either you work from front to back or back to front. That is again something that you can decide within your production, where you can really reduce your setup times of your machines, but still in a way be flexible because the sizes are changing. This then gives you the chance of producing multiple things out of a single component with multiple drilling patterns, but the initial drilling patterns are always the same, so there's always a repeat involved. Once you've created the standard modules, what we usually do is we create a matrix so that you can really see the combinations that you can actually do with your standardized modules. Working in the system 32. I've met manufacturers. I once had a manufacturer who was making kitchens the last 20 years and he didn't know about system 32 until I showed him. And I think most of us know about the system 32, but it's really, really a wonderful thing. And that's where all the hardware dimensions come from, out of the system. So if we really try and standardize into the system of this 32 millimeter hole lining, it just makes everybody's life so much easier. That also influences the sizes of your shutters, drawer fronts, these kinds of things. Some people would say that the clients want to have more flexible, they want to have X sizes, but most of the times it's up to the skill of the salespeople. They can usually sell whatever they want to. So it's not always the client's decision. Basically the marketing or salespeople should really focus on selling something which supports the production more. And that will then once again support the price. The time per shift, downtime is mentioned, and the setup time for a batch. With a normal non-standard, you can see that you can. Oh shit! There's the setup time is mentioned in minutes. So normally the setup time would be much higher than if you're doing a standardized. So you're showing that your standardized system has reduced your setup times of the machines, which then increases the processing time because, of course, logically, you can use the machine for a longer period of time. Machine utilization to turnover. I think everybody's interested in turnover, and profit, of course, but usually more higher turnover gives you more profit if you're smart. So if you're thinking about percentages of machine utilization to percentage of increased turnover, just by standardizing your products, in this case the kitchens, you really can do more and earn much more. Production documents. So many productions that don't work with correct documents. Especially if you're working batches, you need some type of documentation in your production. If you're working in stacks or in the trolleys, all these kinds of things, you have to have some documentation to understand where your products are, what is the next step of your product, where the product is going. These kinds of things should be mentioned so that everybody knows on the floor what is happening with this product, what is the next step of the product, where has the product come from. These are the kinds of documents that should be developed in a production. many productions you see, and there's not a single paper on the floor. The papers are in a file somewhere in some supervisor's office, and that doesn't help anybody. So, and also not handwritten documents. They should be proper designed and developed documents for your production. Because when anybody's on the floor in the production, they should really be able to identify products immediately. In this case, for example, we have different colors. You can even do a color documentation. If you do a red, then it's an emergency product. You have priorities. You can do it. Monday is a different color. You can really play with your documents to understand your production in a much better way. Same goes with barcoding. The same goes with Kanbans. The same goes with all kinds of things. This documentation is a really important thing, which if you're planning your production correctly, if you're processing and creating the data correctly from the beginning of your production, all of this documentation is really not difficult. The last thing is quality control. It's really such an important topic because checking your quality at the last stage or at the customer, that is a really expensive habit. Something being rejected at the last instance is a really, you're playing with fire and a lot of money. So quality control should be from the very first stage, from the order entry, even from the planning department, checking the drawings, checking everything. Even there the quality should be checked. So we always, in productions, you create quality checkpoints, quality gates, or you have to specify exactly when and where you're checking the quality. So as an example, in an example production, this is the layout of a kitchen factory. So we have some saws and some edge banders and all kinds of things. But we're just specifying where the quality will be checked. And you have to be particular about this, because if there are ever rejections, you want to be able to follow and find out what actually caused the problem. So we call them quality gates. So we make these quality gates in the production at the spot where you want to check every single time, where you keep your documents, where you keep all your quality related utensils, and that is where you check the quality. Also very important is to be able to analyze your quality data. It's recommendable to standardize your defects, because there are only X amount of defects that you can have in the production. If you're talking edge banding, the edge banders have 5 to 10 aggregates in the edge bander, and each one can cause a certain defect. Some of the defects are shared. So it's really not difficult to standardize your defects, so that once at the end of the day you can really analyze and understand in which process the actual defects have happened, so you can actually do what we call the root cause analysis to find out where the defect has come from, how we can resolve the problem and avoid it in future. Then with all this data that you've collected, of course you do a wonderful statistic. This the quality controllers usually do for the bosses, so the boss can see which machine is giving the most defects, so that one day you can understand and maybe think about changing it or doing some major servicing to the machine. So all this you can do if you really standardize your quality control data, standardize your defects, and analyze it carefully.